All available experts, please report to room A9.
Hello guys, Exeter here. Today I should be going over the module Diophantine equations. So in this module we're going to be finding out, one, if this Diophantine equation has solutions. It either have none or an infinite family of them. And then finding a set solution based on this equation down here. So let's first set up what it asks us here. So we have this matrix underneath A, B, C, and D. A, B, C, and D being the coefficients here for X, Y, Z, and W. And it includes the negative signs. So we have the X is actually a coefficient of 1. So we have 8, 10, and negative 4. Forgot to put the pacing on, so yeah. And then 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0. And then finally 0, 0, 0, 1. And now it asks us to pick the leftmost closest number to 0 that isn't 0 from the top row. In this case, we've got a lucky case of 1. Because if we look in the next row, pick the leftmost non-zero element in the top row that's different from the M column. Since we have 1 here, and we can't have fractions, we're going to be using this column for all of our calculations. So this is a lucky case that we just...
Emergency cleared. All personnel, please return to your stations.
This top row is going to be the only one that has different numbers in it. These ones are going to stay as 1s. But say if we had 2, 8, 10, and negative 4. Actually, 3 is a better example. And then we would pick this one. We would find the biggest number, which is smaller than 8, and a multiple of 3, which is 6. Which we multiply by 2, we multiply by 2, and then we subtract the 2 off of that, so this one would become negative 2. And this number up here would end up being 2, meaning this is now the closest to 0. And it will be using this column for the rest of the calculations instead of this one. But since 1 is the smallest number we can have that isn't 0, we'll effectively only be using this column for all of these. So, it's nice and simple. Find an integer q such that q times n plus r equals k. Well, the q is going to be k, aka the number, and r is going to be 0. Can we multiply m1 by that number, we get 8. Then we multiply the value of the column that m belonged to. Multiply values of the column that m belonged to by q, so by 8, and subtract this from the column that k belonged to. So this up here, this column is subtracted from this column 8-fold, so we have negative 8. And then it will be the same for the rest of the columns because we had 1. Because if we go back up here, pick the leftmost closest number to 0, that's still 1. And we're going to be subtracting it from this column instead, so this will become negative 10, and this will become positive 4. And then after that, all of these will now be 0. So we now have our 4 rows. Of course, if like my other example of 3, 8, 10, and minus 4, you have the top row be some numbers. The second row possibly also be a set of numbers, and so on. But getting 1 is a nice lucky example because it reduces the work. But now we have to check L is the number we have left, which is 1, and if n is not divisible by L, 7 over 1 is 7, so that is a multiple. But say if we end up with L as 3, and our number was 7, 3 over 7, 7 over 3 is not divisible, so it would have no solution, and we will press the submit button here. But since we do have a multiple, we're going to be doing this calculation. A1, B1, C1, D1 is your top row, A2, second row, and so on. But what are these T values? If L belongs to the ith column, L being, remember, the number we had left, so if we talk about this first column, T is n over L. N over L was 7 over 1, or 7. So, going to take through calculator, we have 7 as our first T value that we're going to be multiplying something by. Our second value is going to be, if the I symbol is the serial number, so we're going to be looking at the second T now. So the second character of the serial number is a 5, which is a digit. So T of that one is just going to be the number, so 5. T3, well, that is a 0. So that was going to be 0. So technically we wouldn't have to put it in, but I'm going to do it just for consistency's sake. Right, T4, we have M. If the I symbol is a letter, then T of I is the alphabetical order of the letter modulo 10. M is 13, modulo 10 is 3. You can have negative numbers here if either this number was negative or your coefficient was negative and you divided it by a negative number. Or what I mean is, where the L ended up being a negative number, and this was positive, so then you would get a negative coefficient for this as well. So now let's substitute each of these numbers in. This will give us the answers for X, Y, Z, and W. X is going to be a bit more work than the others. So in 1, negative 8, negative 10, and 4, we get negative 21. So we type negative 21, submit, and if we got it right, it will let us submit the number and it won't give us a strike. I think it will strike you immediately. You can see here, if the solution doesn't exist, just press S. If the solution doesn't exist, just press S, meaning if this step was true, we would skip to here and then just press S. But also, pressing S to submit between every answer, incorrect and incorrect answer would issue a strike. So if our X was wrong there, we would have immediately been handed a strike, and we take it back to the equation. Thankfully, Y, Z, and W are going to be nice and easy here, because all of these go to 0. I mean, it's just going to be the coefficient of the second term times 1, which is 5. And this is going to be the same for the rest of them. So Z was 0, and W was 3. We press submit, and we have a self-module. So hopefully you now understand how Diophantine equations work. I had a very simple example there, but do be warned, if you don't have a coefficient of 0, you don't have a coefficient of 1, the calculations might be slightly more difficult, because you might have different values, but it's going to be the same thing. If this number you end up with on the top here is not... If the answer to the Diophantine equation, aka n here, is not divisible by this, you press 3 immediately. Otherwise, you use the numbers you end up in these columns by trying to reduce it down to one number at the top here, following these rules. So say with this example, 3, the k is going to be 8, for example, which equals some q times 3 plus some r. Well, we can have 2 and then plus 2. 2 times 3 is 6 plus 2 is 8. So we're going to be subtracting. We're going to be subtracting the product of these, so ignoring this bit, and then this number will become the r. So this will become 2. Now this is closer than 3 to 0. So for the next one, our m, will be 2 rather than 3. So just be wary of that. But hopefully you understand how I have a rough idea how a Diophantine equation works, and I'll see you guys in the next tutorial.